So there you are, sitting in math class, like any good student, and you're trying to pay perfect attention. You really are. But you just can't seem to follow whatever nonsense the teacher is droning on about. And so like any good student, you nudge a person sitting next to you and start a game of tic-tac-toe. However, after a few games, you notice that there's no winning strategy, and you and your opponent have won and lost the same number of games. You also have games that end in a draw. This leaves you pondering, are there alternate versions of the game that have more interesting strategy and results?
Well, what if you increase the size of a board to a 4x4, but you still keep the 2-player rule? Would it still work the same way? Would there be a winner? You nudge the person next to you who gives you a weird look because the tic-tac-toe board is now 4x4 instead of what you originally played with. You decide to keep the same rule of winning diagonally, horizontally, and vertically, only now it's 4 in a row. You quickly realize in the third game that no one has won yet. No matter who went first or where you placed your O or your X, every game has ended in a draw. And you get the idea that this pattern will continue. You give up on this idea, but then another idea pops in your head.
What happens when you add a third player? It is clear right off the bat that you need a bigger board, and so you keep the 4x4 game board. But then, what is considered winning in this new game? 3 in a row? 4 in a row? The classic 3 in a row seems reasonable, and so you stick with that. However, after playing a few games, you soon realize that almost all of the games are ending in a draw, and you become uninterested in this version as well. The person next to you dozes back off, and you're back to where you started.
Okay, what about changing the board to a 3D 3x3x3 version while continuing to have 2 players? You get the attention of the person next to you and once again begin this new game. It seems confusing at first, but you both get the hang of it quickly. After a couple of games, you notice that whoever goes first ends up winning most of the times. After sneaking a peek at your phone to see if Google knows anything, you find a book called A Possible Win Strategy for the Game of Cubic, written by Eugene Mihalko in 1976. He proved that whoever went first can easily win the game if the players have the same skill set.
It is now clear that there is a first player advantage to this version of the game. So what can you do to change this? The 3D version of the game was intriguing, and so you decide to define a single game board as a plane on a cube that is expressed as a regular 3x3 tic-tac-toe board, either horizontally or vertically. A game cube is defined as all of the game boards placed together such that they create a 3x3x3 cube. This is represented on a 2D surface on your paper in a vertical stack of 3 3x3 boards. What if you change the definition of winning? In the normal game of tic-tac-toe, winning is defined by being the first player to get a sequence of 3 in a row, either horizontally, vertically, or diagonally. You decide that it would be more interesting if winning was now defined as getting 2 sequences of 3 in a row, either horizontally, vertically, or diagonally. Once you start playing, you notice that there is more even distribution between which player is winning. However, this leads you to realize that there are better 3 in a rows to get first, so that you can set yourself up to get a 3 in a row more quickly. The middle square of the middle board seems to be noteworthy, and if you go first, then you can take this square. So maybe the first player winning strategy isn't actually gone. With this in mind, you come to the most important question of all. What is the winning strategy for this particular version of tic-tac-toe?
This question seems to be related to the middle square that you already noted as important, but what specifically is it that makes the middle square so interesting? This seems like a worthy investigation, and so you begin to count the number of 3 in a rows that you can achieve using each of the different squares on the GameCube. It isn't long before you notice that there are the most possible ways to win using the middle square, almost twice as many. You also note the symmetries in the number of wins. Now, you have evidence that the middle square of the middle board is important. Therefore, by using this middle square for your first 3 in a row, you can set yourself up better to win again. However, you remember that in the normal version of tic-tac-toe, the second player can block the first player from winning, making the game end in a draw. This makes you wonder about the second player in your game. Can the second player block the first player and prevent them from winning?
You slow down and begin to carefully consider each of your moves. Before making your first move, you remind your opponent that you have to get 2 sequences of 3 in a row in order to win. Going first, you take the middle square of the middle board. You then take one of the 8 corner squares so that you are setting yourself up to get a diagonal 3 in a row through the GameCube. Your opponent blocks to move your 3 in a row. You move again and set yourself up to get 3 in a row in 2 different places. And even after being blocked in one place, you are able to get your first 3 in a row. Your opponent is then able to get their first 3 in a row. However, you are then able to play to set yourself up to get 3 in a row in 2 different places. So when your opponent blocks you in one place, you play in a different spot and win the game.
Eager for a rematch, your opponent challenges you to another game. Since you went first in the previous game, you let your opponent go first, and they copy your strategy and take the middle square of the middle board. You decide to take one of the 8 corner squares. Your opponent picked up on your past strategy, and they take the corner square in their second move. In these first games, the first player has won, and you keep playing until you have sufficient evidence that there is a winning strategy. You will win this version of tic-tac-toe if you go first and take the middle square of the middle board, and in your second move, you take one of the 8 corner squares.
Now satisfied with your expertise, your mind begins to wander once more to things that seem now more interesting, like what happens on a 4x4x4 board? Does the same winning strategy work? What about a 5x5x5, or even higher than that? What would happen to the winning strategy if we eliminate the middle square of the middle board from the game? Will the first player still have the advantage and win? What would happen if you change the number of players, or the number of 3 in a rows you must get to win the entire game? The ringing of a school bell indicating the end of class jolts you out of your thoughts, and as you scramble to put away the remains of your discarded game boards, you find yourself, maybe, possibly, looking forward to your next math class.